Okay, now that I have my pen back, let's go ahead and continue. And we're looking for the greatest common factor and least common multiple for both 8 and 44 and 7 and 9. So let's go ahead and start with 8 and 44. Smallest prime number to go into 8 and 44 is 2. 2 goes into 8 4 times. 2 goes into 44 22 times. Well, I can still take 2 from both 4 and 22, smallest prime number 2. 2 goes into 4 2 times. 2 goes into 22 11 times. And I'm looking at 2 and 11. Well, there is not a factor that I can pull out of 2 and 11 other than 1. And that's going to give me 2 and 11 back again. So I'm going to stop pulling out factors here. Now, I'm going to look at the numbers on the outside of my step-down method. I'm going to look vertically. And I have 2 factors here. 2 times 2. That's going to be my greatest common factor. 2 times 2 is 4. So going down is my GCF. When I multiply across, I'm going to circle these numbers. And I'm going to include the product that I have on the outside. And this is going to be my LCM. So I've got 2 times 2 is 4. 4 times 2 is 8. 8 times 11 is 88. So I've got my least common multiple. Notice I multiplied my GCF by the factors remaining at the bottom to get my least common multiple. Well, now let's think, does this make sense? Is there an 88 in the 8 table? Yes, 8 times 11. Is there an 88 in the 44 table? Yes, 44 times 2. So I have an 88 in both the 8 table and the 44 table, and I have a factor of 4 in both 8 and 44. So I've got my greatest common factor and my least common multiple. So now let's take a look at 7 and 9. And is there a prime number that goes into both 7 and 9? Well, no, there's not. But there is a factor, and that's a factor of 1. 1 goes into 7 7 times. 1 goes into 9 9 times. Again, I'm going to look outside of on the outside of my step down process, and I have a greatest common factor of 1. Now I'm going to look at the factors that I have remaining at the bottom, and this is going to be my LCM. Remember, I'm multiplying my greatest common factor and the factors remaining to find my least common multiple. So let me put my greatest common factor of 1. And 1 times 7 is 7. 7 times 9 is 63. So now I'm going to think, is there a 63 in the 7 table? And yes, 7 times 9 is 63. Is there a 63 in the 9 table? Yes. 9 times 7 is 63. So I have a greatest common factor of 1. I have a least common multiple of 63. Very nice. In this lesson today, we're going to take a look at least common multiple and greatest common factor, and how to know when to use each one, and then how to calculate both the least common multiple and the greatest common factor. So here we go. First, we're going to take a look at characteristics. The greatest common factor is the greatest or largest factor common to 2 or more numbers. Your greatest common factor is smaller than or equal to the numbers. Your factor cannot be larger than the 2 numbers that you're using. 2 or more numbers. Doesn't have to just be 2. Least common multiple is, again, the least or smallest of the multiples of 2 or more numbers. Least common multiple is equal to or larger than the numbers that you're finding the LCM for. So now let's take a look at using a Venn diagram to find both the greatest common factor and the least common multiple of 12 and 18. well, first, I've prime factored 12. 2 times 2 times 3 are the prime factors of 12. 2 times 3 are the prime factors of 18. So I'm going to look to see where there are factors that are common to both that I can put in my central area for my greatest common factor. And I see that they each share a 2. And they each share a 3. So I know that they're sharing a 2, they're sharing a 3. 2 times 3 is 6. So my greatest common factor for 12 and 18 is 6. Well, that gives me the greatest common factor. What about the least common multiple? Well, I'm going to multiply 6, which is my greatest common factor, times 2 times 3. And my least common multiple is 36. So let's think about this now. In my 12 table, I have a 36. 12 times 3 is 36. Okay, I have my pen now, so let's take a look at finding the greatest common factor and least common multiple for 8 and 44, and then for 7 and 9. So let's start with 8 and 44. And I have my setup here. So I've got my step down division, and I'm going to think the smallest prime number to go into 8 and 44 is 2. So 2 goes into 8 4 times. 2 goes into 44 22 times. Smallest prime number to go into 4 and 22. Well, that's still going to be 2. 2 goes into 4 2 times. 2 goes into 22 11 times. Smallest prime number to go into 2 and 11. Well, there isn't one. So you're done with your factoring. The numbers on the outside going down vertically is going to be your greatest common factor. So I'm going to multiply 2 times 2. 2 times 2 is 4. So your greatest common factor for 8 and 44 is 4. Now I'm going to look at the numbers across the bottom. I'm going to circle these, and I'm going to multiply what I got from my greatest common factor by the factors that are remaining. So again, I said 4 was my greatest common factor. 2 times 2 is 4. 4 times 2 is 8. 8 times 11 is 88. My least common multiple is going to be 88. Well, now let's think. In my 8 table, is there an 88? Yes, 8 times 11 is 88. In my 44 table, is there an 88? Yes, that would be 44 times 2 would be 88. So I know that 88 is a multiple of 8. It's also a multiple of 44. So I have my least common multiple. I have my greatest common factor. Let's take a look at 7 and 9. Smallest prime number that will go into 7 and 9. There isn't one. But there is a factor, and that factor is 1. So 1 goes into 7, 7 times. 1 goes into 9, 9 times. So now I'm going to look at my factors on the outside. I have 1. I'm going to look at the factors that are remaining that I cannot factor out anymore. And vertically, I'm looking at 1 is my greatest common factor. And now I'm going to multiply 1 times 7 times 9. And I'm going to get a least common multiple of 63. So now I'm thinking, does this make sense? Well, is there a 63 in the 7 table? Yes, 7 times 9 is 63. Is there a 63 in the 9 table? Yes, 9 times 7 is 63. My greatest common factor is 1. There is not a prime number that I can pull out of 7 and 9. And hopefully a number of you realized, or all of you realized, 7 is prime. And there is not a factor of 7 in 9. 9 is not a prime number. It's a composite number, but it does not have 7 as a factor. The only factor that they both share is 1. So now you have completely factored out the greatest common factor for 7 and 9, that is 1. Least common multiple is 63. Greatest common factor for 8 and 44 is 4. And least common multiple is 88. Nice job. In my 18 table, I have a 36. 18 times 2 is 36. So the greatest common factor are the factors that they both share that I multiply together. That is 6. Then I take the rest of my factors that are not shared by both and I multiply those in to get least common multiple of 36. So let's take a look at another one. How about 8 and 12? So I've got my prime factors for 8, 2 times 2 times 2. I have my prime factors for 12, 2 times 2 times 3. Again, I'm going to look at which ones they have in common, and that's going to go in my center circle for greatest common factor. So I know they share a 2. I know they also share another 2. And in my overlapping area, it's going to be 2 times 2. Well, the greatest common factor for 8 and 12 is 4. Now I have a 2 left on the 8 side and I have a 3 left on the 12 side. That's not included in my greatest common factor. So my least common multiple is going to be 4 times 2 times 3. And my least common multiple is 24. Well, now I'm going to think of my 8 table. Do I have a 24 in my 8 table? And yes, 8 times 3. Do I have a 24 in my 12 table? Yes, 12 times 2 is 24. So both 8 and 12 have a multiple of 24 in their tables. That's my least common multiple. The greatest common factor is 4. When I'm using a Venn diagram, that's what I would be looking at. So now, I can use the step-down method for prime factoring, and I can get both my greatest common factor and my least common multiple. How would I do that, you say? Well, I'm going to put both 8 and 10. I'm looking for the greatest common factor and the least common multiple. I'm going to put the 8 and 10 inside of my step-down division sign. And I'm going to look at what is the smallest prime number that can go into both 8 and 10. And that smallest prime number is 2. 2 goes into 8 4 times. 2 goes into 10 5 times. Now I'm going to look at 4 and 5 to see if I can continue. Is there a factor of both 4 and 5 that can go into each number? And there is not a prime number that will go into both 4 and 5. So I'm going to look at the outside of my step-down method, and the only factor I have here is 2. So my greatest common factor is 2. Now, to find my least common multiple, I'm going to take a look at what I have for greatest common factor and any factors that are left over here. And I'm going to multiply them together. 2 times 4 times 5. 2 times 4 times 5 is 40. So my least common multiple is 40. So let's double check that. When I think of my 8 table, do I have a 40 in the 8 table? And yes, I do. 8 times 5 is 40. Do I have a 40 in the 10 table? Yes. 10 times 4 is 40. So there is a multiple of 40 in the 8 table, a multiple of 40 in the 10 table, and my LCM is 40. My GCF is 2. Okay? So let's take a look at another example. And I'm looking at the GCF and the LCM for 16 and 12. So I know 2 will go into 16. I know 2 will go into 12. That's my smallest prime number. So 2 would go into 16. Well, that would be 8 times. 2 would go into 12. That would be 4 times. I'm sorry, 6 times. 2 goes into 12 6 times. So 2 will now go into 8 4 times. 2 goes into 6 3 times. So I'm looking at the outside of the step-down method, and I have 2 times 2. Well, my GCF is going to be 2 times 2, or 4. My LCM, remember I said I'm going to take the numbers on the outside, and I'm going to multiply that by factors that we have at the very end. So my LCM is going to be 2 times 2 times 4 times 3, or 48. So thinking of my 16 table and my 12 table, is there a 48 in the 16 table? Well, if I'm thinking of 16, 16 times 3 would give me 48. So yes, there's a 48 in the 16 table. 12 times what would give me 48? Well, 12 times 2 would give me 48. So there is a multiple of 48 in the 16 table and the 12 table. So now, use the side-by-side step-down method to find the GCF and the LCM of 8 and 44 and 7 and 9. So I'm going to see if I still have my pens. Okay, so we're going to take a look at some of these examples, and I'm actually going to be trying something a little different, and hopefully this will work. I'm going to go back and forth between a blank page where we can work the equations together, and then back to the examples. So keep your fingers crossed. We'll see how it goes. Taking a look at number 1, I have a triangle with an angle of 43 degrees, 60 degrees, and a missing angle. Remember, to find the unknown angle, I want to add together the 2 angles that I'm given. I'm going to write my equation. You know that the total measure of the triangle is 180 degrees. So let's see how we can work out that first one. Okay? Hopefully this is going to work. And number 1, we had 43 plus 60 plus x equals 180 degrees. I'm going to add these 2 terms together. 103 plus x equals 180. Remember, this is an addition equation. You're going to undo addition by subtracting. I'm going to subtract 103 from each side. These are going to cancel out. 103 subtract 103 is 0. And x equals 77 degrees. Good job. Okay, so that's how you solve your first one. Remember your steps. Write your 2 angles given, what you have given out, include your variable, equals 180. because that's the total measure of all angles in a triangle. So we're going to get ready for number 2, and let's take a look at our second one. We have 40 degrees, 30 degrees, and an unknown angle. So again, we're going to do the same thing. We're going to write our equation and solve for the unknown. So this time, I have 40 degrees plus 30 degrees plus, and this time I'm going to put D, equals 180 degrees. Even though the book has an X there, I'm going to put a D just for something a little different. You're going to add together your two terms. This is going to be 70 plus D equals 180 degrees. Again, you have an addition equation. You're going to undo addition with subtraction. That means I'm going to subtract 70 degrees from each side, and D is going to equal 110 degrees. So your missing angle is 110 degrees. Nice. Let's take a look at our third one. This figure here, we're going to need to do a little bit of thinking with this one. This figure shows some of the folds that need to be made to fold a paper airplane. Find the unknown angle measure X. This is what I'm looking for right here. This unknown. So I'm going to come back to my worksheet. I'm going to move this up a little bit. Give myself a little bit more room so that I can have this blank area. And I'm going to see if I can pull out, put this off to the side here so that I can still see this but work on this page. And I think this is going to work. All right. So to begin with, I need to find this missing angle. And I am looking at these two here. I know that 50 and whatever this is here, these are supplementary angles. So I need to first find what this would be. 50 plus N equals 180. Remember, I'm looking at my supplementary angles. I'm not looking at everything right now. So this is all I'm focusing on. I know that if this is 50 and this angle is part of this same line here, these are supplementary angles. And I know that's going to equal 180 degrees. So I'm going to subtract 50 from each side. And N is going to equal 130 degrees. Well, now I know that this angle here is 130 degrees. So now I can find my X. Now that I know this is 130, I can continue, and I've got 130 degrees plus 23 degrees plus X equals 180 degrees. This is going to be 153 plus X equals 180. You're going to isolate the variable by subtracting 153 from each side. And X is going to equal, what are you going to get when you subtract that amount? And if you said 27 degrees, you're absolutely correct. So remember, when you have an example like this, you first need to find this missing angle here. You're either going to have complementary angles or supplementary angles. And once you find this one here, now you've got two angles in this triangle, because this is the shape. This is your triangle right here. And to find what this is, you first need to find the supplement of the 50. Okay? So let's see if we can take a look at a few more. Okay, I've got 60 plus x. Well, again, you're going to write out your equation. 60 plus x equals 180. 60 plus 60 is 120. 120 subtracted from 180 is 60. And if you looked at this and said, you know what? These angles all measure the same. You're right, you have an equilateral triangle. Three sides are the same and all three angles are less than 90 degrees. Now let's take a look at 65 degrees, 78 degrees, and x. Same thing. On your paper, add these two together, plus x. Isolate your variable, and get your answer. And if you found that x equals 37 degrees, nice going. The last one that we're going to take a look at, again, the same process. Add your two known angles together, plus x equals 180 degrees. Subtract the total from here, from 180, and x is going to equal 32 degrees. Very nice. Okay, so we're going to continue, now that I've got my pen, in finding the GCF and the LCM. And I'm taking a look at 8 and 44. And the smallest prime number to go into 8 and 44 is going to be 2. 2 goes into 8 4 times. 2 goes into 44 22 times. I'm looking at 4 and 22. The smallest prime number to go into 4 and 22 is going to be 2. 2 goes into 4 2 times. 2 goes into 22 11 times. So now I'm looking at 2 and 11. Smallest prime number to go into 2 and 11. Well, there isn't one. So I can't factor this out anymore. So to find my GCF, I'm going to have 2 times 2. 2 times 2 is 4. My greatest common factor for 8 and 44 is 4. Now I want to find my least common multiple. So I'm going to take a look at everything that I have vertically and everything that I have horizontally. 2 times 2, we already said that's 4 for my greatest common factor. So I have 4 times 2 is 8. 8 times 11 is 88. Well, now let's see, does that make sense? Is there an 88 in the 8 table? And yes, 8 times 11 is 88. Is there an 88 in the 44 table? Yeah, 44 times 2 is 88. So my least common multiple for 8 and 44 is 88. Now, let's take a look at 7 and 9. The least prime number that will go into 7 and 9. Well, there isn't one. Is there a factor that will go into 7 and 9? And the factor is 1. And I'm going to take a look at, well, 1 would go into 7 times. 1 would go into 9 9 times. So now when I'm looking for my greatest common factor, the only common factor I have is 1. So my greatest common factor for 7 and 9 is 1. And now I'm going to take a look at multiplying my factors vertically and my factors horizontally. 1 times 7 is 7. 7 times 9 is 63. Well, now let's think. Does that make sense? In my 7 table, is there a 63? Yeah. 7 times 9. In my 9 table, is there a 63? Yes. 9 times 7. So your greatest common factor for 7 and 9, because there's no prime number that will go into both 7 and 9 evenly, is 1. So that's your greatest common factor. Your least common multiple is going to be 63. Very nice.